So let's continue with Russell Stevens, who is a mobile infrastructure lead at Compass, a company that builds software for real estate agents. Actually, Russell has been working in the mobile app development business since he bought his first iPhone in 2011. He has a great experience in developing apps for many different clients. And today, Russell will talk about scaling mobile developer productivity. So if you have any questions during his talk, please use the Q&A tab and ask your questions there. And now, Russell, I give the stage to you.
Thank you so much. Welcome to Scaling Mobile Developer Productivity. So what is this talk about? This talk is about, if you've worked in mobile, or maybe you've heard this, as the mobile team grows in size, there's normally a natural tendency for the feature velocity to decrease. So as you're adding more people to your team, over time in a mobile development setup, you may actually move slower than when you had a smaller team. So I really want to talk through how a team dedicated to mobile infrastructure could actually help. What is mobile infrastructure? You could also think of it as a DevOps team that works on mobile issues. Normal areas of responsibility for a team like this would include, Xcode maintenance, dependency graph, monitoring the crash free rate of the app, the overall build system, CICD, and really trying to optimize the developer velocity and just increasing that through all of the other teams that maybe are more feature focused in your mobile org. So who am I? My name's Russell. I'm the mobile infrastructure lead at Compass. I've been working in iOS for about 10 years now. I've worked on various different apps, various different sizes for various different use cases as well. I've worked at Compass, Hinge, Abercrombie & Fitch, Hollister. I've also, in a past life, worked on some DoD and military applications, all for the iPhone and iPad. I've worked on mom and pop hardware store apps. I've also was a solo app developer in the early days of the App Store as well. So when you talk about mobile, you always need to start by talking about shipping, right? So how does a mobile release work? And how is that maybe different from shipping a web front end or a back end? So there's 6 parts to releasing a mobile app. The first would be deciding that your code ready. So you would cut a release, you would compile that into an archive and actually ship that to your app store. And you would wait anywhere from an hour to 3 days for a review. Then you go through like a third-party review. So Apple or Google, if you're developing Android, can actually say this is okay to release or this is not okay to release. If you pass that review, then you would go into the actual app store and then your customer would download the app. If at any point during these 6 phases, you discover an issue or a problem or something that causes you to go back and restart, you have to go back and you have to restart this whole process. So it's not as simple as deploying one web page or one backend service to wherever it would live in the cloud. This whole thing needs to compile and it all needs to go out together. So however many teams you have, all of them need to decide that that mobile version is ready to ship. So in the early days of working on mobile, so maybe you're an early startup or it's the beginning of your project, you'll probably tend to move fast. Technologies and things that you could use to help you move fast would be basically using like a linter to make sure that all your styles are the same, you're conforming to the same code output. You definitely want to align on the architecture that your company is going to use. You want to try and lower the cognitive load of PR reviews and just reviews in general. The more aligning you can do up front, either in person or on the ticket or in planning, is going to help you versus on the PR trying to solve the problem there. So in the past, we've actually set an upper limit of maybe 200 lines for a PR. And this way, over time, you're just kind of layering in all the changes and they're going in very quickly with minimal amounts of conflict or questions being asked, because the team should be avoiding nits like nitpicking and shipping as needed. So in the early days of an app, you'll almost always ship or release mobile when a critical feature is launched. And on the right here is just a picture of a standard setup. Maybe you have a repository, you have a single app in there, and all the testing you do is done right on a phone. So this way, there's that tight feedback loop. You make a change, you run it, you see how it is, and then you decide that it's ready to ship. So over time, right, as your mobile team grows and your feature set grows, you kind of graduate into this sort of either enterprise or more production focused app state, where maybe your app has a whole bunch of features inside of it. And they all live inside of that mono repo. All the features live within the same target. All the QA that's required to ship it happens on your app binary. Maybe you introduce some CICD streams, like a beta app that either gets shipped every night or every time you merge a PR. You'll have a release candidate or an RC build, which is every time you know you're going to release to the App Store, you want to test and kind of freeze those commits before they go out. And then you have a production app as well, which is always great for triaging a customer issue. If you get a new piece of feedback coming in, you want to see exactly what they saw on that version of the app that was shipped. So over time, you might start feeling the weight of ownership. So what is the weight of ownership? You can imagine that if you had one box, right, and all the features were on them, it's kind of blurry lines, unintentional code sharing is happening. You may not know that the change you make on your feature actually breaks the change on another feature. So over time, if the workflow kind of graduates to this natural tendency to just be kind of more tightly coupled to each other, you'll see that there's going to be a high amount of coordination required to get the app out the door. When a feature change blocks another feature, that will need to be coordinated and understand, why did we make that change? Should we revert the change? How do we make both features happy in order to continue shipping the app out the door? At Compass, we actually noticed that as we added all of these features, say in the range of 20 to 50 features, that the manual regression steps that we were doing started to increase the amount of time it would require us to vet the app and say that it's regressed or okay to release to the store. That time actually grew from, used to be a couple of hours, used to be something that anyone can do, to something that became highly specialized. And also took a lot of time. It actually took us 80 hours to be able to say every single thing that we want to provide to the app and to our customers is actually okay to release. So over time, as it became harder and harder to release, because naturally someone would make a change, it would break another feature, we really put our heads together and said, how could we actually make this scale? How could we make it so that when we merge the code and the features are done, we know that when we go to ship it, we won't have this high coordination, feedback loop that we're kind of stuck in. So we had two sort of paths that our team took. And this was the genesis of making a mobile DevOps team as well, to kind of own these two areas. The first would be all of those manual regression steps that take us about 80 hours. Let's start automating them. Let's find the lowest hanging fruit and just find a way to solve it in code and then maintain that code. Secondly, we wanted to improve the overall architecture. And you can think of this as either the feature architecture or even the macro architecture of how teams interact within a mobile code base. And we were going to do that by taking a lot of what we learned in the back end over the past 10 years in terms of like microservices, where do you draw the lines, and try and actually establish that on mobile, drawing heavily on reality. Uber did this a few years ago. I think a few other companies as well, like Kayak and HubSpot and things like that. So there's a lot of documentation out there, but it's kind of a little bit out of date as well. So we had to leverage these things, but also kind of develop what would work best for our flavor of mobile development as well. So we started exploring modular, right? So modular architecture is one of these buzzwords you hear a lot. The way we think of it is how could teams become more autonomous? So when a team decides that they are ready to ship into the mobile app, they could actually be empowered to release the app on their own. So the first step here would be drawing the lines, right? Actually dividing code into either feature sets or team-owned areas. We did this, and I'll start using more iOS comparisons as we move forward. We actually started creating additional dynamic libraries inside of our main repository that became dependencies of the main app. So we were able to pull out infrastructure components, things that empower features to leverage almost like tools in a toolbox. So teams that were more feature focused would be able to leverage these tools and focus on just using the tools to build their features and ship the app out the door. So the first couple of things we were able to pull out would be infrastructure related to routing. This would be how we change from screen to screen when either a push notification or a universal link would actually be actioned and brought into the app. The next thing would be the automation of our test reporting. We were leveraging a tool called TestGrail, which is basically like a big spreadsheet with a unique ID for each line item that you would like to regress. And we were able to add a little bit of tooling around that to automate that manual report as we started introducing these changes. Then we were actually able to take some product features and leverage these tools almost like a toolbox and prove out that this concept actually worked. And we were able to do this in 2020 during our first quarter. And this started to demonstrate some value for our team. So the immediate value that we saw was that there was a 20% reduction in the amount of test cases that we had. Sorry, let me rephrase that. So we were able to decrease our total automation, our total steps of what we regressed to 20% automated, 80% manual. And that leveraged a 60% time savings, reducing the time it took us to actually QA the app and say that it's okay to release. It reduced it from 5 days to 3 days. So we were also able to revamp our manual QA process by not testing anything that passed an automation test and only focus on the things that were not yet automated. And the edge cases of things that were automated that failed, we would retest those manually. So next, once we had these boxes kind of separated, what we wanted to do was explore how could we maybe move these to another repository and lock them in place, almost like open source or SDK development, but internal to our company. So what we were able to do is take these dynamic libraries and push them into their own repositories and actually version them in a way that works very similar to if you've used CocoaPods or any sort of package manager. It takes a release version of that framework and pulls it into your main app. So what we're doing is we're starting to explore how, as we draw the lines and actually move code into different boxes, that those boxes can then be versioned and actually used as dependencies for our main app. So once we did that, we had these sort of SDKs that were ready and being leveraged as dependencies for our main app. We wrapped them in their own app as well. And this is something we started calling a sandbox. So you could imagine if you had a feature and you just wanted to test the subset of whatever lives in that feature, and that was a separate framework from the rest of your main app. What if you wanted to make a quick change? You wanted to change either like a button color or some text inside of the repository where that feature now lives, which is separate from the main app's repository and the main app code. You could run that library with an app and actually make a targeted change and prove it all out inside of that separate repository, push up the PR, have it be merged, and then you could actually version that and update that dependency in the main app. So sort of starting to redefine how we actually approached our mobile development workflow by almost scaling what we would call like the smallest part, or the easiest way to make the change would be to make that change in isolation, and trying to perfect that and scale that across all of the features and all of the teams that we have at Compass. So the goal of this would be, once we had those lines drawn and those things were actually separated, it should enable us to fail faster and also like move faster. So I say fail faster as in, you make the change in isolation, you catch it on that Sandbox app. You're not catching it on your main app during regression ahead of when you're trying to release. And if you remember those 6 stages of mobile release, if you fail at any point in that time, it actually takes quite a bit to recover between the coordination and just restarting that process from the beginning. So if we look just deeper into what is a feature sandbox, you can imagine that this is the SDK or the library that would be a dependency of the main app. It's wrapped inside of its own test harness or test app. We call it a sandbox. This would be a non-production area for you to write just testing code. If you wanted to inject yourself into a certain flow, instead of needing to go into the main app, log in as a certain user with a certain level of access, go through the enterprise navigation where features are sometimes buried and you have to find the right flow. This just allows you to inject yourself right into the right context or flow or page that you want to be on and make those changes in isolation. So how do we scale that now across all of the teams and enable those teams to release independently? If we take the features that we were starting to isolate in our main app repository and over time decouple them from each other, we could actually pull them to separate repositories, version those repositories, introduce new sandboxes for those features, and also start taking the manual QA regression steps that we had on the main app and push those down onto the feature level. So manual and automation, which we're trying to reduce manual steps and introduce automation at the same time, at the immediate benefit of, from the main app's regression, moving all of or most of the regression down into the feature module level. So this way, immediately releasing that app becomes faster and faster and easier. And then within the feature level, adopting more automation just snowballs that effect and things start moving faster and faster. So at the end of 2020, we're actually able to get our spot to 80% automated tests. So we had about, for context, maybe 1,800 test cases, and we automated 80% of those. And just because we were able to leverage technology and then running those tests in parallel and running them on demand, we were able to get our release time down from 80 hours to under 5 hours. We actually stopped at 4 hours. And this is kind of where our dependency graph landed at the end of the year. So much emphasis of getting these things in place requires a lot of testing, and testing before you release and testing even before you want to release. So I just want to do a deeper dive into how we actually approach testing as well. So like I mentioned, we were able to get that regression time down from 5 days to 4 hours. That's a time savings of 90%. And this graph shows from roughly like halfway through the year of 2020, how as we automated a higher percentage of our tests and optimized the way we were regressing and where those regression tests lived in our dependency graph and our overall, mobile stack, the green line tracks the time it took us to regress. So you can see at the end of the year, we actually were able to get down to 4 hours. So this would be, you're in the main app, you have all your dependencies, they're somewhat partially regressed or fully regressed at that point. You cut a release, within 4 hours, we have confidence that all the issues are known or fixed and ready to be shipped to the App Store. We're able to do that, like I mentioned, by automating the QA reports directly within the code. So leveraging Swift and actually extending these XC test cases for how you run unit tests and automation tests to capture those test results as failures or passing test cases, and uploading those things via the API for TestRail, which is our vendor for these things, we're actually able to not write these reports manually, but also generate these reports on the fly anytime we would want to run our testing stack. So to have a testing stack that you maintain, you also want to fail fast there as well. So this is a glimpse into one of our monitoring dashboards of the health of our tests and our test suite that we run ahead of regression and at regression time. So we leverage a tool called Datadog. Datadog is it's like an SDK you can drop in your app, and then it captures whatever metrics and properties you want. You go onto their site, and then it builds charts based on that data for you. So some things we're able to actually track here would be the overall pass-fail rate of UI tests. When people talk about UI automation, naturally it starts heading towards these things are flaky, you shouldn't rely on them. We're actually trying to isolate those reasons and dig into what are the root causes for why tests might be flaky for most people. And we do that by a process we like to call Kaizen, which is what's the next best action or the smallest change you can make that just moves it in the right direction. So we have these sort of top lists of what are the longest running tests? What are the top failure reasons? What are the overall top failing tests in general? And should we remove them, rewrite them, action on them, make them faster? It gives us so much clarity into, we just wanted to do one thing. What's the next best good thing we can do? It also allows us to monitor the health of the suite ahead of when we would actually cut the release. So each day we can come on and see what is the pass-fail rate. We have monitors in case the dip of success goes down like greater than 5%. We know that there's a major problem. We can start catching it ahead of release day as well. So now let's look at what does our renewed focus on this release process look like for mobile. So first of all, with mobile, it's always great to fail fast or have a tight feedback loop. So when you make a change, you want to see that change as fast as possible. So this is how we revamped our CICD pipeline to catch things faster. For each change that a developer might make or a change in our workflow, there's some sort of corresponding output continuous delivery available. So say you're a developer, you're making a change locally in Xcode, you can run that on the phone and see whether or not it meets your sniff test, right? You could submit a PR and we'll generate what's called an alpha build. That PR can be merged to main, and that will actually trigger a beta build. When we go to cut the release branch, we actually trigger what we call a release candidate or an RC build. And at each level through here, we're actually regressing more and more, but also failing faster and faster and knowing when to go back and address something ahead of cutting the release, to the point where when we actually tag our release branch, we have all of the build process automated and uploaded to go directly to test flight and actually submit itself for review. We do the manual release of an Apple review. So this way, Apple will put it in the queue and review it as fast as possible, but not release it until we say that we have finished our regression. So we're almost able to take that sometimes upwards of 3 days for review and start that process earlier and just let that time, that we're already spending work for us as well. The next thing we started leveraging within the manual release is the 1% ramp that Apple gives you. So they'll give you a 7-day ramp that you can opt into. And at any point in time, you can kind of just ramp it to 100%. So for 1 day, we ramp the app to just 1% of our users, and all of the testing that we do beforehand, we actually run it through some of the same checks in production at scale. So this way, if there's anything like in the crash free rate, overall usage is down, or maybe the launch time increases, we can know that we should abort that release, take our old release that was just in production, bump the version there, and then release that within 5 hours to Apple as well. And what does this process actually do for us? As we're adding more people and more features and more things to our mobile development workflow, we're actually able to release faster, which is actually kind of crazy. So in the past, our releases used to be ad hoc. Then they moved to correspond with like a sprint schedule. And now we actually were able to get them down to weekly. So every week we are releasing an app and we're fully confident in what we're shipping out of the door. So some of the pain points here are that looking back, the level of effort to get here was super, super high. The effort to launch a new project or actually like bootstrap a new feature is still high. And for us at Compass, the build system is still in its infancy. We, at this point in time when these slides were made, we didn't adopt Xcode 12, SwiftUI, Combine, SPM, all things that we know from the Apple lens we do need to adopt. So the time has come to stretch what we thought was like possible or necessary with mobile infrastructure. And this is where we actually start scaling the idea. So the state of mobile today, we like to think of it as 3 tiers. We have an app that sits on top of all of the features, that sits on top of all of the infrastructure. And it's a dependency graph that flows up. So from the infrastructure tier, that's available to all the features, and then all of the features are available to our single app. But if we also wanted to have more than one app, we could start making decisions on which features go into which app, and then reuse that regression in QA that we do throughout the development workflow ahead of releasing to one or many apps. So how do we do this? First of all, you need to scale your build system. So we actually developed a CLI, which we've written originally in Ruby when we were using CocoaPods. We're still in the process of migrating to SPM. So what we have is a Swift CLI that actually has all of everything we would need to run on CI, or anything that would be a script that needed to be run on a developer's computer is all centralized in this CLI and packaged and available to our team. So this way, all of that code is reused across all of the repos. Some rules we had to introduce would be the features within the feature tier. They cannot import each other. Cannot have any circular dependencies here, because then everyone is just on top of each other like they were in the beginning. So instead, they're decoupled and they need to coordinate through the infrastructure tier. We leverage this by using like a coordinator pattern. It's like semi-event-based. We're still kind of solving this problem, but this allows us to say, if I want to go from feature 1 to feature 2, all of that coordination can happen independently of a feature. So features do not talk directly to each other, and that's what allows this process to scale. So why are we using these sandboxes? Basically just to isolate the easiest way to make changes and scale, and then repeat that across all of the teams. So naturally, this is the building block for the entire piece of the puzzle. And that's why we're going to build in our CLI the ability to actually generate these sandboxes. So we have the CLI, we've adopted some tooling with Twist, which is a Xcode project generator, and a few other tricks as well, to generate a new repository with a new Xcode project with some sort of template, and also all of the YMLs that are needed to run on CICD as well. So at the end of the day, where will this actually put us, right? As we go to add new features or add new apps, we could leverage this tooling to actually bootstrap new pieces of our dependency graph within minutes. And they're fully functional and fully available to the feature teams as we either split teams or come up with new features or split apps, or if you want experimentation apps and things like that. All of that tooling is now available to a feature team person to just kind of come in and say, I'd like a new repo that uses MVVM or uses SwiftUI and Flux and things like that, and just kind of have all of these tools available out of the box. So if you want to learn more, I actually did a podcast with Bitrise on a deeper dive into the history with a little bit more detail about how we were able to go almost like the genesis for mobile DevOps or a mobile infrastructure team, the need, where it came from, and actually what it becomes and what can it be. And then also, if you want to check out any mobile related posts from Compass, here's a link to our blog as well. And that's all I have for you.
And actually, we have many questions here. So let me start with the one that got the most votes. How do you decide when a feature deserves to have its own repository and an app?
That's still something we're learning. And I think as we solidify a lot of our learnings here, we'll share more. Right now, we're following a principle which is called Conway's Law, which would be you structure your code or your dependency graph to meet your org structure. So if a team naturally owns more than one feature, why not have the repos be team owned? And then this way, the teams that work on multiple features have everything they would need. And then those PRs actually get opened in the team repo. So then all of your teammates are there and available for review. And there's no noise from other teams or other features that you really don't care about.
Super. Another question from Milan. These changes are great that you have done. How big is your mobile engineering organization? Just to have an idea. And how do your mobile teams look like? How they are built up?
When we started this process, the team had scaled from about 2 to 5 to 10. We really had a lot of the troubles of coordination around 15 to 20. Since then, the team's actually almost tripled. So I think we're north of 50 just for iOS right now. And at the same time, 50 on Android as well. So the team has been growing as we've put this in place. We're actually still speeding up with our velocity. So I would imagine we haven't even hit like the upper bound of, does this work for 1,000 people or 5,000 people or 10,000 people, and I guess time will tell how that works out.
Great. Another question from Zsolt. Who should be responsible for assembling the finished app from certain versions of the feature modules? The team can work separately, but how do you manage the integration?
That's a great question. And as we're still taking features, this is live, right? So we're doing this and we're sharing what we've learned so far. We wouldn't say we've solved the problem either. There are still some features that live in the main app. There are still some regression steps that live in the main app as well. And once we move them, we actually hope to get the regression time down to an hour and maybe even 30 minutes on just the app. So who should actually own it in the ideal state? I would imagine that drawing on other industries here, you might see in maybe more like the IoT or the hardware business, sometimes there's like a release or a configuration team that sits on top of the whole process and owns like the release schedule and the updates and the coordination of those things. I could almost imagine where if you know what features or workflows that an app needs to provide, imagine if there was almost like an IDL for designing workflows of the features that they provide. And then maybe the main app is really just a config that loads those contexts onto either a container or something like that. And even that container could be instrumented for boot time and performance and things like that as well.
Thank you. And the last question also from Zsolt. Is there a need to keep the different features using the same tech stack? The separate teams may drift regarding what tools to use. Doesn't this open the door to redundancy?
Yes, it does. So right now we actually do move lockstep. Lockstep meaning you talk about semvar, right? Even the patches need to be propagated throughout the stack. And this is actually where I would say is about to get the most amount of attention from our team, which would be how do you maybe enable opportunistic versioning or locking it maybe to the minor instead of just the patch. So this way, things that are actually semantic patches don't require everyone to move lockstep and actually do resolve when you actually get to that top app tier. The way we want to do that is by auditing the public API, by measuring churn of each layer. So the churn of the infrastructure tier, we want to get that down to a point where every minor or every major makes sense and it actually has a reason. Right now, I'd say the APIs are still kind of being drawn. Some of the things that we had need to be decoupled further, re-architected, or redesigned. But if you can measure that churn and then Kaizen that churn down, you would be able to actually say, this is a patch and build a piece of tooling that either runs on a PR check or a release phase and says, actually, this needs to be a minor because it has a breaking change. And if you could actually detect what's a breaking change and what's not, what's maybe like not a public API change, you could enable that opportunistic versioning and maybe redundant in the feature tier. But when it actually goes into the main app, most modern dependency managers like SPM, CocoaPods, all of that stuff will actually resolve it to the correct version. And as long as you have the right tooling that didn't put yourself into a breaking change that cannot be resolved, then at that point in time, you likely are shipping something that is measured correctly, does have quality. And we're hoping to actually solve that problem in the next 6 months.
Thank you so much. Well, no more questions. So thank you so much. And we would like to mail this mug to you with your image on it. So a little bit different look, but still that's you. So we really would like to thank you, and the whole Craft team would like to thank you for your interesting presentation.